Okay, let's get started on some percentages. So the word percent means per 100. So 5 over 100 is equal to 5%. Now we already know that 5 over 100 is equal to 5 100ths. So we can make this connection here that 5 hundredths is actually equal to 5%. So that brings us to the definition. And the definition of n percent is that n percent is equal to n over 100, meaning whatever number this is goes over a 100, and the 100 is always 100. Okay, that never ever changes when you're talking about percentages. Let's take a look here. Also note that it says where n is any non-negative number. We're not talking about negative percentages here. Okay, so let's take a look at 1%. That's 1 over 100, and 78% is 78 over 100. But I want to point out that students often have trouble when the percentage is greater than 100. So be sure that you spend ample time and you test them over the idea of the fact that there are percentages that are greater than 100. A good place to start in understanding what a percentage is a decimal grid. I've got two examples here. The first decimal grid here has got 33 colored squares. 33 over 100 is equal to 33%. And this one here actually has 14 colored squares over 100, which leads us to 14%. So we're going to look at converting fractions into percentages a couple of ways, and the first way is to rewrite the equation or rewrite the fraction to have a denominator that's equal to 100. Now we used this technique before when we were introducing decimals and the idea of place value, so we're going to do the same kind of idea here. What we're going to do is notice that 5 times 20 is equal to 100, and because that's the case, then we're going to multiply top and bottom here by the number that it takes, and that in this case would be 20 over 20. Okay, and when we do our shirts times shirts over pants times pants, we can see that we come out with 40%. Another way to do it, and it's really a clever, kind of tricky way to do it, but we want to recognize that 1 is actually equal to 100%. And since 1 is equal to 100%, we're going to exploit that idea here. We're going to start off with our 3/4 and we're going to multiply it by 1. Remember, multiplying by 1 is the multiplicative identity, so it's not going to change anything. And then what we do is we convert it to a percentage by basically multiplying it by 100 and dropping this old percentage sign here down. So we have 75 hundredths times 100%. So we do the math with the 75 and the 100, and then we add the percent sign on. When we're converting a percent to a decimal, we're going to use the fact that 1 100th, 1 over 100, 1 100th, and 1.01, 1 100th, is equal to 1%. And the way that we're going to do that is we're going to replace the percent sign, we replace with this 0.01, and then you do the math and that gives us our decimal. Now I want to make note here that it's pretty important that excuse me, your students understand that the percent sign on its own carries carries its own weight, it means that it's whatever the number is times 100 and the percent sign. Okay, so keep that in mind, and here's kind of an example to kind of help you see that. 1/2 is equal to 0.5, and 0.5 is equal to 50%. But 1/2% is equal to 0.5%, and that is actually equal to 0.005, because if we were to work this out, we'd have 0.5 times 0.01, and that gives us our 0.005. I think it's kind of a clever way to look at it. All right, so a tool that you can use in modeling percentages, especially helpful in working application problems and such, is a percent bar. So it's basically just a bar broken into 10 groups, and every group represents 10%, as you see here across the top. Each section, when you get to the bar, is going to say that you've hit 10%. In other words, each block here is worth 10%. Okay, so we're going to see how to do this. We're going to use a bar to find 40% of 70. So I've set up a percent bar here, and I highlighted the 40%. And over here I showed that 100% is actually equal to 70. And the best and easiest way to do this, and there's several different ways to do this, don't get me wrong, there's a bunch of different ways to do this, but when we're talking about the percent bar, it's really, really good to start with what is 10% of 70, okay? Because that's pretty easy to figure out. So we could say 70 times, convert this guy to a decimal, and we would get 7. Okay, so we can say that 10% of 70 is 7, and if each block is the same length, which it is, then the next one will be 14, and the next one will be 21, and so 40% of 70 is going to be 28. Okay. Another way you could have done it is you could have said, well, half of 70 is 35, and then subtracted 7 from it. That's the only other really obvious way I could think of, and this was half of 70 equals 35. Then subtract 7. But it's way easier to start with figuring out what that 10% is, because then they can just scale it on up. Okay, there's also double measurement model that we can use to find 60%, and when you do this, you put 2 number lines on top of each other and basically do the exact same thing that we did using the percent bars. This is helpful if you don't have any percent bars, hadn't printed them out. I mean, everyone can draw a line with their handy dandy ruler and mark it out. It's a good skill. It's great for fine motor skills and stuff. So if we're here at 70, if 10 steps is 70, then 1 step is 7, and we'll just go ahead and do the exact same thing. Jumping up by 7, and here we get to 42. So 60% of 70 equals 42. All right, well, let's look at the three kinds of percentage problems you'll be dealing with. The most direct way to solve these percentage problems is through proportions, and we definitely studied a whole section on proportions when we were in chapter 6. So there are three basic types, and I'm going to do an example of all three types. And the first type is finding the percent of a number. Okay, what is 30% of 12? Okay, finding what percent one number is of another. So what percent is 17 of 40? And finally, finding a number when the percentage is known. So something like 30% of some number is 12. What's the number? Okay, that's an example of the three different kinds. So let's work our way through. So let's look at the first kind. Finding the percent of a number. Without a doubt, this is the easiest one for students to generally do. When you're dealing with percentages, you already have one full ratio. And remember, to solve a proportion, let me remind you that proportions are ratios. It is a fraction, let's go A over B, is equal to another fraction, C over D. And we know that these guys are equal, and to solve, we can cross multiply. Okay, which is why this is such a direct method. You don't have to come up with some sort of scheme that 1% is equal to 0.01 and convert it to a lot of things. You can just go straight for it. Now, the one thing that you need to make sure that you understand, that your students understand, is how to convert between percentages and rational numbers, and that they have to do proportions in rational numbers. In other words, the proportion is a fraction equal to a fraction. Okay, so we've got to have a fraction equal to a fraction, and so we're going to set up our 40%. So 40 over 100 is equal to x over 30, where x is equal to the number of boys. It said 40% are boys, so we're looking at the number of boys here. And so to solve this guy, we'll just cross multiply here. We could say 100x is equal to 40 times 30. So 100x is equal to 1200. X is equal to 12. So there are 12 boys in the class of 30. You should also be modeling what you want your students to do for you when they answer questions for you on assessments. So I'm going to suggest you always have them write the answer of a word problem in a sentence. That does two things for them. First, it actually connects the math and what the math is actually finding from it just being some sort of rote problem that they're doing. And secondly, it kind of tests again if they understand what that answer actually means. So it's super important to do those kinds of little things. It increases your effectiveness in the classroom. Next, let's see the second scenario, which is finding what percent one number is of another number. So here, George scored 24 out of 32 points on a quiz. What is his percentage? Now, you want to focus sometimes on the fact that this says, what is his percentage? And remember, if we don't know what that percentage is, then we already know we have x over 100 because that in and of itself is the percentage, right? So that tells you how to set up the other two pieces. Now here it says 24 out of 32 points, and we've already studied how to set these ratios and proportions up, so we know that we're going to get the out of goes in the denominator. So we've got 24 out of 32 is equal to x out of 100. Now I rewrote this because I simplified. You want to have your students try to put their work in simplest form before they actually even have to crank through. I'd much rather deal with 3 and 4 than having to deal with multiplying through with 24 and 32. So always encourage people to make their work a little bit easier for themselves. And then here we're going to go ahead and do the cross multiplication. So we have 4 times x is equal to 3 times 100. So we have 4x equals 300, dividing by the 4 here, x is equal to 75. Okay, so George scored a 75%. You don't say George scored a 75. You need to write that, say that percent, because that's what we're doing here. It's very important. Okay. The next one asks us to the scenario is finding a number when the percentage is known. So here's our example. Isabel went to the zoo, which featured 84 big cats. If the big cats make up 21% of the animals in the zoo, then how many animals total are in the zoo? So again, you want to instruct your students to look for helper things in their word problems. And the helper thing here is the fact that we have 21%. Because we have 21%, we know one of the two proportions. So we have the 21 over 100. I don't know what I did wrong here. I didn't pay very close attention here, but this is great because I made a mistake, and I don't hate that I made a mistake, and I want to point out the mistake because this is a very common mistake, and I'm just cracking up noticing that I actually made that mistake. So here's the idea. We're almost always going to set it up as 21 over 100, and that forced me to write x over 84 because it's a pattern, right? We've been doing that all along and everything, but I forgot to be really careful like we were when we did the proportions. And when we do proportions, it's really important that everything lines up together, right? And so 21 is the cats over the total. And here I wrote this as the total over the cats. So this is wrong, and this is a mistake. And I'm really not sure. I guess maybe I planned on doing it that way, but when I wrote the lecture a day ago, I forgot. But anyway, I'm glad that this came up so I can point out this thing because this happens all the time. Okay, so it's important that we keep everything aligned, right? And so if I write it like this, if it's 100, then 100 is the total. And the bottom here is the number of cats. It's 21% and the 84 count. So still, we're going to solve this the same way. We get to cross multiply here. So we have 21 times x is equal to 8,400. Divide through by x. X is equal to 400 120, I think. Oh, darn it. I don't really want to mess up here. But y'all, it's late. This is the 4th time I've tried to record this evening since I got home from work, and I'm just give out. Let me check what that math is. I'm going to use my calculator, and then if it's wrong, if I made a bad problem, then I'm really going to just be sad. Oh no, it's 400. Hello. Good. Hello. You guys already know that arithmetic is not my strong suit. So 400 total animals in the zoo. Awesome. I survived it. Okay, come on, let's go. We got this. 3 more slides. All right. Alternatively, we can do the same problem, visualizing it using a percent bar. So I have a percent bar here. I have shown the 21% stands for 84 of the animals, and 100% is I don't know how many animals. And from there, you could work the proportion. For sure, if you've got someone that needs the visualization, this is a good place to start on the proportions. But we can also do it in a little bit different way. This is the different way. If we look and say 21% is equal to 84, and we want to get 1%, then all we have to do is divide both sides by 21, which is what I did. And so now we know 1% is equal to 84 over 21. And we also know that 100% of x is equal to 1% times 100. Right? If I want to know what 100% of x is, and we multiply 100 times 1%. So therefore, we can now say that 84 over 21 times 100 is equal to 400. Okay, so this is just kind of like a really weird way of them figuring out what that 100% is by using that 1% idea. Okay, and then you can't hardly talk about percentages without talking about money, and you can't hardly talk about money without talking about interest. And so here we are, we're going to talk about computing simple interest. And there's a few variables that go inside here. The first variable is A. That's the amount in your account after your interest has been applied. You've either paid interest because you're borrowing money, or you've been paid interest because you're saving money in a savings account. Interest is the amount of money that you pay for using the bank's money, or the bank pays you for basically using your money. When you have money in a savings account, the bank is using that money. They're basically borrowing that money from you, and that's why you get a little bit of an interest if you're in an interest-bearing account. Anyway, the next variable is P, and that is the principal, and that is the original amount borrowed. Oh, excuse me, I'm going to yawn. The next is R, and that's the interest rate, and that's the percent of the money that you're going to be charged to borrow, or that they're paying you to borrow money from them. And then T is time, and time is specified. Time is the specified amount length that interest is accruing, and it's always measured in years. And when we're talking about simple interest, time usually is measured in years, but could be measured in months. And if it was measured in months, like, for example, 8 months, then we would use 8 months is 8 over 12, which is 2/3 of a year. So you would use 2/3. Or sometimes it's daily. So maybe it might be something like 100 days. Maybe you borrowed money for 100 days from a loan shark that's charging you simple interest. Sorry, I'm tired and punchy, and it's not really that funny. But 100 days would be 100 out of, and how many days are in a year? 365 days per year. The reason why this denominator here is 12, because there's 12 months per year. And here, this guy is 365 because there's, let me do it in a different color so it doesn't all just be red, because it's 365 days in 1 year, and we're measuring in years. Okay, I want to make that point clear. And then finally, the amount in the account, so A is equal to your principal plus your interest. And to get simple interest, it is principal times rate times time. This is how you get the I. So here is our principal, here is our interest. And what I did is I manipulated the problem and I pulled out that common P. You could work the problem using either form. Doesn't matter. One's a little bit more sophisticated. So let's work one example here. It is important now, you cannot do any real math with percentage signs because they have that inflated place value. So we always have to convert our percentages to decimals. So you must convert to decimal to do operations on percentages. Okay. So here we have 5.25%, which is 5.25, which is equal to, notice this is not a percent yet. This is going to be a mistake your students are going to make a lot, okay? This is not a percent yet. To make it a percent, we've got to move that decimal place. To make it a decimal, we have to move that percent 2 places to the left. Y'all, this is the last one, and I know I am just so tired I cannot even do it. Hold on. Rewind. I would rewind, but I don't like the way that turns out. Maybe I'll try one more time. No, we're going for it because I'm going to be done in like 5 minutes. Okay, here we go. Hi. This is the worst one of my whole semester. Okay, sorry. I need to make note to myself that I need to re-record this next semester when I teach it. Okay, so 5.25% is equal to 5.25%, which is equal to 0.0525. Okay, this is what I was trying to get my mouth to say, but it didn't want to say, and my fingers didn't want to do it either. Okay, now when you do these kind of problems, it's really important for you to kind of write down the variables. And let me write down the equation again. A is equal to P plus PRT. This is the way that I'm going to work the problem. Okay. So we need to know what A is, P, R, and T. And one of these is going to be missing, and I do this with all of these problems that I do. So we're going to come back here. First, let's see the obvious here, which is 1 year. So T is equal to 1. We know that. Now let's go back up here to our problem, and it says we opened a savings account paying 5.25% simple interest. So we know that our R is the 0.0525 that we just figured out. Okay, let's keep on going and see what else we can figure out. Annually, all right. If she deposited $5,000, so there we go, $5,000 is our P, with no additional deposits, what is the total account? What is the total in the account? That is A. That's what we're looking for. So we don't know what A is. That's what we're looking for. So let's set this up and write it in our equation here. So A is equal to P, which is 5,000, plus P, which is 5,000 again, times R, which is 0.0525, times 1. And let's see, by the magic, I know I got this done. When you add all of that together and do the math, we get $5,262.50 in 1 year. Now, I think the question said, oh yeah, it also asks us, what's the interest? And the interest is this piece right here. This piece is the interest. And there's two ways you could figure it out. You can actually do the math there, or we could find the interest using this clever little equation. And the equation is A is equal to P plus I. So we can say I is equal to A minus P. So interest is equal to the amount in the account minus the principal. So if the amount in the account is $5,262.50, and we subtract the original amount, which was $5,000, then you can see that our total interest was $262.50. Total interest earned, because this is a savings account, so they're getting the interest. They're not paying interest, they're getting paid interest from the bank. The bank's borrowing money from them. Okay, and then I wanted to look real quick about what happens when it's in 90 days. So we have everything is the same here except for T. T here is going to be 90 over 360. Okay, and when we clean that up, let's see, 9 goes into 36. 36, 9 goes into 36. My brain, y'all, I can see it, but I can't do it. Let's see, the zeros come off. 9 goes into 36 4 times. Good dear Lord. So that is equal to 1/4. So when we do this one here, we're going to have A is equal to 5,000 plus 5,000 times 1/4 times 1. This is R, this is T, here's a P, here's a P, using this equation up here. All right, and when we do that math there, we get $5,064.73. And we can say that there is, in 90 days, and the interest earned was $64.73. Okay, well, by an absolute miracle, and it was an absolute miracle, in several takes and a couple of pauses and a few faux pas, mistakes, and going backwards, I've made it. So y'all have a good one.